Hey everybody, and welcome to How-To Videos with Dr. Amy Gates. This video is an example of a full one-way ANOVA test. We're going to run the entire test by hand, use the F-table to get the critical values, and come up with a conclusion. At the very end, we'll also take a quick look at how we might run a test like this using Excel. So in this particular test, we're looking at the number of ounces of coffee consumed every day by three different groups of people. The first group are Italians, the second group French, and the third group American. Remember, we use ANOVA testing when we have more than two groups that we're comparing. We also use a one-way ANOVA test when we have only one independent variable. In this case, our independent variable is ethnicity, and our three groups are Italian, French, and American. Our dependent variable is what we're comparing. We're comparing the amount of coffee consumed by each of these three groups. Now, some ANOVA tests will come with data, and some will simply come with information that was collected from that data. Either way, the test is run using the same methodology that you'll see here. Using a gigantic data set, I created results from that data. So here's what I have, and here's what's given in the problem. The first group, which is our Italians, has 70 people in the sample. There's a mean of 4.0. That's a sample mean. That's the number of ounces of coffee the Italians drink each day. That's the average for the group. And the sample variance. S squared stands for sample variance. The sample variance for the Italian group data set was 4.4. Same thing for the other two groups. My second data set, my French data set, had 70 people in it. Their mean coffee consumption was 3.7, their variance was 5.2. For the third group also, 70 people in the group. 3.4 was their mean for coffee consumption, 6.1 was their variance. So whether you start with the data and make these calculations, or whether you simply start with these calculations, the following process is identical. So there are several steps to running an ANOVA test. The very first step is to make sure that you have recorded for yourself the total sample size that you have for all of your groups. We have three groups in this ANOVA test. Each group has 70 people, so that's a total of 210 people, and we'll call that capital N. You'll notice the different textbooks sometimes use different letters for things, so it is best to understand what's going on rather than to memorize the letters themselves, because sometimes that can get you into trouble. The first step in any hypothesis test is to create the null hypothesis and the alternative hypothesis, and so that's what we're going to do here. The null hypothesis always represents that all of your groups are statistically the same, and so you'll always find equal signs in a null hypothesis. In our case, we have three groups, and our null tells us that there's no significant difference between any of our three groups for coffee consumption. Therefore, the mean for group 1 equals the mean for group 2 equals the mean for group 3. The alternative or research hypothesis is that there is a statistically significant difference between one or more of these groups. And so HA looks very much like HO, except it contains the not equal signs. If any one of these groups is statistically different, the ANOVA test result will be significant, but we'll come to that. In the second step, we have to calculate all of our degrees of freedom so that we have that information when we're ready to calculate the actual F test. The first degree of freedom that we'll look at is called degrees of freedom between. This is for between our groups. We have three groups in this case, so DF between is always the number of groups you have minus 1. So in our example, our DF between is the number 2. Again, we have three groups. You always subtract 1, and so our DF between is 2. Next, we need to calculate the DF within. In order to do that, we first take the complete sample size of each group and subtract 1 from it. And that gives us 3 sets of 6 nines. Then to get the DF within, we add up those values. So 207 is our DF within. And you might have also seen that as just simply adding up all of your samples and subtracting by the number of groups you have. And that'll give you the same exact answer. So these are the two different degrees of freedom we need to calculate for ANOVA. df between is the number of groups minus 1, which is 2 in this case. df within is going to be each individual sample size minus 1, and then you sum up those three values. So here are our two df values that we will use once we get to calculating the f-test. That was step 2. In step 3, we're going to use an f-table to determine the cutoff value for our f-test. Remember, whenever you run a hypothesis test, whether it's a z-test, a t-test, an ANOVA test, you need to know your critical values. In other words, your cutoff values that will allow you to determine whether your result is significant or not. The cutoff values tell you where the rejection region is. So if you have a cutoff value and your f value is to the right of that or larger, it's in the rejection region. But we'll see what that looks like in a moment. Now there are two ways generally to figure out cutoff values. One is to use a table, the other is to use a technology. In this example, I'm going to show you how to use the table, but then when we look at Excel, we can see that we can quickly use Excel to calculate the p-value, which is even faster. So let's scroll down a little bit to see what it looks like here. Remember, we calculated the degrees of freedom above. We said, and let's back up and see what those were. We said that the degrees of freedom between was 2. This is used for the numerator on the table. And we said the degrees of freedom within was 207. This is used for the denominator of the table. So let's go to the table now and see what this looks like. There are many f-tables out there, and keep in mind that no single f-table can possibly contain all values because there's an infinite number of values. So in most cases, you'll look across your numerator. In our case, our degrees of freedom for the numerator, that was our between, is 2, so that's this column. And our degrees of freedom for the within, or denominator, was actually 207, if you recall. The closest value in this table to 207 is 120. So I've used this row. That means that 3.0718 is my critical value for this particular f-test. So again, my degrees of freedom was my column, my degrees of freedom within was my row, and that value that intersects them, so that's at df2 and df120, is my critical value. So about 3.07. Again, I'm using 120, but if you look at a similar example, someone may have a slightly larger f-table. They might have another value stuck in here, and so this value might be slightly different. And that just simply happens depending on the table you're using or the textbook you're referencing. All right, now we have our critical value, but now we need to see what our f-test result is. So again, we know our cutoff for the critical region is 3.07. Step 4 is to run the actual f-test so that you have your f-value and you can see whether that value is larger than your cutoff or not. There are several steps for running an f-test by hand, and we're going to go through them. The very first step is to calculate what's called the grand mean or the total mean. These words are slightly different from textbook to textbook, so it's best just to understand what they are because that makes it a lot easier. The total mean is an average of the means of all three of your groups. Remember, we said the amount of coffee that the Italians drink was 4.0, the French was 3.7, the Americans 3.4. This was the mean, each sample mean from our table. The average of each of our sample means is 3.7. That's called the grand mean or the total mean. We added up all three of our means, divided by 3 because that's how many means or groups we have, and we got essentially the average of our averages. And that's what this value is. And we're going to use this value in the second step. Remember, we're calculating the t-test, and there are several steps. So the first step is to get the total mean, which is the average of the three means of our groups. In the second step, we're going to calculate what's called the variance of our means. It seems a little complicated, but it really isn't. You take each mean of your group and subtract that grand mean that you just calculated up here. So remember, the first mean group, the Italians, drank 4.0 ounces of coffee. We're going to subtract from that our grand mean, or our average mean. Also, the French drank 3.7. We're going to subtract from that our grand mean. And the Americans drank 3.4. We're going to subtract from that our grand mean. In other words, we took each of the means from our original groups and we subtracted that grand mean, or the average mean, that we calculated above. Once we make this subtraction, we square it. So notice in each case we make the subtraction and square it. We make the subtraction and square it. Once we square each of these, we'll sum them all up and then divide by our degrees of freedom between, which in this example was 2, and we calculated that above. So when we take the difference of 4.0 minus 3.7, we get 0.3. When we take the difference of 3.7 minus 3.7, we get 0. When we take the difference of 3.4 minus 3.7, we get minus 0.3. Now we're going to square each of these values. 0.3 squared is 0.09. 0 squared is 0. Minus 0.3 squared is 0.09. Now we're going to add all these up. Then we're going to divide by df between, which was 2. So in this case, the variance of means, which we'll call s squared m, comes out to 0.09. It certainly cannot be negative. That would be impossible. All right, so what have we done so far? First, we calculated the grand mean, which was the average of all the means. Then we took that grand mean and we subtracted it from each individual sample mean in our data. We then squared the value. We added them all up, and we divided by the degrees of freedom between, which is 2 in our case. In our third step, we're going to calculate something called the variance between the groups. That's a quick calculation. We take the variance of means that we just calculated above. That's this guy. So we take this result, 0.09, and we multiply it by the size of one of our samples. All of our samples are the same size, but if they weren't, you could use the average sample size. But each of our samples is the same, so we're lucky there. And we'll multiply that value by 70, our individual sample size, and that gives us our variance between, which is 6.3 in this case. In our fourth step, we will calculate the within variance, which actually takes all of the variances from our original table of information and takes their average. So if you recall, and let's look at our original table, if you recall, we had individual sample means. We also had individual sample variances. In the fourth step, we're going to take all 3 of these sample variances, add them up, and divide by 3. That's going to give us an average variance for all 3 samples. That's what's going on down here. Let's scroll back. So we added up all of our variances, divided by 3, and that gave us an average for our variance. That's called the variance within. Now that we've done these 4 individual calculations, we have what we need to calculate the f-test. The f-test is simply the variance between divided by the variance within. So our variance between was 6.3, our variance within was 5.233, and the division is 1.20. Let's review that quickly. In the first step, we got the grand mean by adding up all the sample means and dividing by the total number of groups. That's sort of an average of the average. In the second step, we calculated the variance of the means. And by doing this, we subtracted that grand mean from each of the individual sample means. We squared each value, we added them up, and then we divided by df between, which is 2 in our case. Then we took this value to go to the next step so that we could calculate the variance between. We took that value that we just calculated and multiplied it by our individual group sample size. All of our groups have the same sample size of 70, so we can use that number easily. If not, we take the average group size and use that number. Now we have the variance between, which is one of the values we're going to use in our f-test itself. Let's look at that quickly. Notice the variance between is 6.3. When I scroll down here, there's that 6.3. That's the numerator of my f-test. To get the bottom number, or the variance within, we have to make our fourth and last calculation, which is we take the average of the 3 sample variances from our table. We add all 3 sample variances up and divide by 3. And that's how we get that last value, the variance within. So by dividing the variance between by the variance within, we get our f-test result, which is 1.20. In our final step, we have to determine whether or not our HO should be rejected. In other words, do we have enough evidence to support the idea that different ethnicities drink a significantly different amount of coffee? Well, our f-test is 1.2, but our cutoff value that we got from the table is 3.07. So 1.2 is not bigger than 3.07. 3.07 is the cutoff for the rejection region. So if we were larger than 3.07, we would say that there is a significant difference between coffee consumption in our groups. However, our result is not bigger. It is not beyond our cutoff. Because 1.20 is less than our cutoff value, we cannot reject the null. We cannot reject the null. So in conclusion, there is not a significant difference between our 3 groups. There's not enough evidence to conclude that people from these 3 ethnic groups, Italian, French, and American, drink a significantly different amount of coffee. Statistically, the amount of coffee consumed is not significantly different. In other words, we cannot reject HO because our final f-test value is not outside of the cutoff. It's less than the cutoff, so we cannot reject HO. We only reject HO when our test value is larger than our cutoff, but in this case, it is not. So again, we cannot reject HO. So to review, we did a full one-way ANOVA by hand. We decided to compare 3 groups for coffee consumption. We knew the sample size of each group. We knew the sample mean of each group. We knew the sample variance of each group. We wrote our HO and our HA. We determined the degrees of freedom between the groups, which is the number of groups minus 1. We also determined the degrees of freedom within the groups by subtracting 1 from each group and then summing up the results. That gave us 207. We used the F-table to get the cutoff value for our F-test by using our DF between as our numerator and our DF within as our denominator value on the table itself. So our numerator value was 2, and our denominator value was closest to 120 because the exact value was not available for us on the table. Therefore, our critical value, or our cutoff value, is 3.0718. We continued down then to calculate the f-test itself by taking all the steps. The first step was to calculate the grand mean, or the total mean, which is an average of all three means from our table. In the second step, we then calculated the variance of the means, where we took each mean, subtracted the grand mean, and squared it, then added those values together and divided by the df between. That's how we got this number. Then in our third step, we calculated the variance between by multiplying the value we had just gotten times how many people we have in each group. In this case, our groups are the same size, so we can use 70. Otherwise, we would use an average. In the last step, we calculated the variance within by taking an average of all the variances from our initial table. These are each of the variances from our groups divided by 3, because we have 3 groups. Finally, to get the f-test, we divided the variance between, which was 6.3 above, by the variance within, which is 5.233 above. That gave us our f value of 1.2. We compared our f value of 1.2 to our critical value, or our cutoff value of 3.07. It was less than our cutoff, so we cannot reject the null. So we conclude that there is no significant difference between coffee consumption for our 3 ethnic groups, Italian, French, and American. Now, if we wanted to do something like this in Excel, so that we didn't have to calculate all of this by hand, we can certainly do that. And this is an example of a program that I created in Excel for doing exactly the example that we just did. The example starts out by saying the number of groups that you have. That's what this is. So we have 3 groups. Notice that the number of groups is located in A2. For those of you who use Excel, you know how important it is to know where each thing is located. So we have 3 groups. That value is located in A2. This is the information that we have. We have our group 1, which I can actually get rid of that because we don't need it. Different example. What's great is all these examples essentially can use the same programming. So we had our 3 groups. We know that the size of each group is 70. We know that the average for the first group is 4, the average for the second group is 3.7, and so on. Here are our variances. Basically, this is the information that we start with. Alpha is 0.05. So knowing this information, you can actually program Excel, if you are an Excel user, to calculate the final f-test result. That's down here. And you'll notice that when I click on this value, it says that it's C13 divided by C15. This is C13. Here's C15. And you'll notice that each one of these has a formula in them. Basically, what I did was I followed all the steps that we just reviewed, and I created each one of these formulas. For example, I started here. Remember, we said we needed the sum of all of our data. So there's 210 total people in all 3 groups. So this is the sum of C4 through E4. So here's C4, D4, and E4, and here's the sum of them. The next thing I calculated was the grand mean. The grand mean was the average of all of the means in our table. So there's our grand mean. And you'll notice that these values are identical to the ones we just went over by hand. I then calculated the degrees of freedom between our groups, which is simply the number of groups, that's A2, minus 1. So that's where that value comes from. Then I calculated the degrees of freedom within. Remember, we said that you can get that by taking each of your samples, subtracting 1, and then adding them all together. So that's why this is the sum of these 3 values, and each of these values is the sample size minus 1. Now, if you're not an Excel user, you may have to view this several times and much more slowly. If you are an Excel user, then this gives you a good overview of how to put these formulas into Excel so that you can then change the numbers in this box and everything else will automatically update, which is very nice. Remember when we started calculating the F-test, we started out calculating the variance of means first. The variance of means was this formula, which looks familiar really. It's the difference between the average and the first value in our table, the average and the second value in our table, and so on. This information will be posted up on mathandstatistics.com along with this tutorial so that you can click on any one of these boxes and see the formula that I used. Once you have this downloaded onto your computer, if you wish, you can change any of these numbers and it will automatically update everything else so that you can run an F-test, really a one-way ANOVA test, automatically. So that's the value of learning how to program Excel to run a one-way ANOVA. I hope this example has been helpful, and you can find this and many other examples on mathandstatistics.com. Thank you.